Hi, folks. So let's go through the broad term workflow of how a C program is typically written. So let's say there are different source files. Excuse me. So let's say this is file 1, file 2, file 3. All right. So all of these files have a bunch of C code, right? Some programmer has written these files, right? This is a programmer, and he has written these files. All right. So what will he do first? The first step is to feed these files to C compiler. All right. C compiler. For each one of those files, and if there are some caveats, we'll see them later. But broad term workflow is this. The C compiler will generate object files. Let's say file 1.o, file 2.o, and file 2.o, and file 3.o. All right. So this is step number 1. That is of compilation. This is step number 1. And after this step, these 3 object files will be fed to the C linker, which is a program. And what it will do is that it will combine these 3 object files, so to say, that is, link them together and create a binary. All right, binary file. So this binary file that is created, so this is step 2. So this binary file that is created is either a direct executable or a library. That library can be used by other C programs. All right. So for example, these libraries at the linking time, these libraries can also be fed to the C linker. Let's say some library file, let's name it library 1. The C linker can be told to link library 1 with these files as well. Ultimately, some human has some purpose that they need done. So ultimately, some executable will be used by a human, right? It will be used. That means it will be executed by or you can say the program will be run on the operating system and it will do, hopefully, what you wanted it to do. So this is a broad term flow. Let's go over it again, all right? Let's see. So some programmer writes a bunch of code in 3 source files. It feeds it to the C compiler. C compile translates. Remember the translation of programming languages? So the C compiler translates each file into a relevant object file, right? Object files, we'll see this shortly. What do these mean? And as step 2, the object files are linked together, potentially with other libraries, to create a binary file, which can either be a library to be used later in some other linking process, or a final executable which has to be run, executed, started, whatever. And it is run in an operating system. All right, so let's see a little more things. So remember, we have a processor somewhere over here, right? And all a processor knows is the instruction set of its machine language, right? Processor knows no C, no Java, no nothing. It only knows the instruction set of the machine language that it supports. This is the processor. All right, somewhere over here, let's say high up in the chain, we have that programmer we talked about. Let's say the programmer wrote something in a bunch of code in file.c, fed it to a compiler, came up with a file.o, which was fed to a linker, which, let's say, generated the output binary. All right. So let's think a bit. What would you expect to be in these object files and in this output binary? What would you expect should be over here in here? What should these contain? Would they contain just, the instruction set? Let's say instruction 1, 1011, followed by 1, 0, 1, 0, 1, 1, 0, 0, so on and so forth. Let's say this is the first instruction. And inside this object file or output binary, 1 millionth instruction is, let's say, 0011. Is this all that an object file or a binary file needs to have, right? Because after all, it actually needs to be run by the processor, right? Is that all there is to it? Well, no. The reason is there is another piece of software which you are very familiar with. It is called the operating system. And direct control of system resources is abstracted out by the operating system. All right. Operating system in turn has a program, a helper program called a loader, whose purpose is to load an application binary and run it, execute it, so that it can work. So this layer of operating system has a lot of responsibilities. An operating system is a very complex piece of software. And hence, because of this reason, the compiler generated output file or the final binary generated by the linker will never contain the direct machine language instructions. They will be there, however, but not in the raw form. And the reason is that the operating system basically, every operating system provides file formats, executable file formats, right? So all operating systems, for example, Linux, Windows, Mac, every operating system defines the executable file formats that its loader supports, all right? And that file in that format is fed to the loader of the OS to execute it. Hence, because of this reason, the compiler manufacturers, compiler makers, and of course, the linker makers, compiler and linker makers, the tool makers for C or any other programming language, make it sure that whatever platform, operating system and processor combination platform, their software tool, compiler, and linker supports, they must support generating the object and binary files, of course, with the right machine language, but also in the right executable file format required by the operating system they support, right? So this is important to remember. And with that, we end this video. I'll share a link of a Quora question and answer as a comment to this video if you want to delve deep into it. All right, thanks. Have a good day.